Swayam Prabha. Digital India. Educated India.
Hi dear friends, welcome to this fourth lecture of Module 9 on Engineering Geological Investigations for Roads and Highways, Bridges and Building Foundation. In previous lectures, we have discussed about bridges, classification of bridges and their working mechanism. Now in these lectures, we will discuss about engineering geological facets of bridge foundation and geoground or strata or layer close to abutment, and then quality of source material and geotechnical evaluation. In these lectures we are going to elaborate about engineering geological facets of bridges and material quality. Regarding this, we are going to cover about foundation and abutment, then engineering geological aspects, types of site characterization, quality of material and geotechnical evaluation. Friends, as you know, the foundation of any structure related to engineering geological structure is very important, because this strata is going to bear all the loads of the structures along with dead and live load. So foundation and abutments of the bridge are very important part of bridge construction, and the total load of structures as well as dead and live load of structures as well as live and dead load of traffic are transferred through foundation on foundation strata or soil layers of geogrounds and side face of hills, either made up of soil, either made up of rock strata or rock mass. The geoground is responsible to bear all the loads transferred through the foundation and abutment of the bridges to the foundation strata or soil layer as well as the slope of hill face. Therefore, it is necessary need for the success of the bridge project to characterize foundation ground and walls of the valley before construction of bridges. The type and design of bridges also depends on the nature of foundation strata or layer. You can see here the superstructure of bridge is either supported by this abutment or supported by pillars or supported by both. Therefore, this strata belonging to the abutment should be sufficiently strong and of good quality to bear the load of superstructure. However, the foundation strata lying below the piers or foundation pillars also needs some specifications related to strength, modulus and deformability, or in terms of the quality of rock mass. So the foundation strata should be sufficiently strong to bear the load of structure transfer through the piers or pillars. For the purpose of overall planning of a bridge project requires preparation of layout of bridge site and related road and railway link at initial stage. You can see the preparation of layout we are going to carried out with help of the survey personnels at different levels to suggest the lithological distribution, suggest the forest cover, soil cover, and different type of problematic zone present in geoground. Then we are going to make some geological sections to show the subsurface condition of strata or soil layers. So the principal work concerned to the engineering geology is evaluation of geological condition in term of lithology, in term of structures, in term of saturation condition, etc. Then preparation of geological map and subsurface status of site through preparation of geological section along a particular alignment, is like this or along this as per requirement and the condition of strata. The evaluation of geological condition is a very important because the geological condition is responsible to overall bear the effective load of superstructure along with dead and live load of traffic or imposed stresses due to different works carried out on the deck of bridge. For this, we are going to map geologically the area and prepare the distribution of lithology along with structure lying subsurface to the area. Regarding the detailed geological investigation with engineering touch as a engineering geological investigations, we are going to first target as selection or evaluation of geoground based on different characteristics of ground in view of geology, in view of geotechnical response, in view of the geomechanical attributes, etc. Then for the subsurface evaluation and subsurface visualization of ground, we are going for the exploration of the site through various exploratory drills and various subsurface mapping techniques involving geophysics and others. Then evaluation of foundation condition, where we are going to put the pillars and going to put the piers, the foundation pillars, etc. Then next important is construction material, that is the source of aggregate and soil material. So the selection and evaluation of bridge size in different terrain is required for proper assessment of the area responding to the imposed and design stresses or force or load. Second, exploration of the site and exploration of the site by drill holes and collection of samples, then laboratory test of collected samples to see about the response of strata or soil layers with respect to expected imposed load due to superstructure of bridge and dead and live load of traffic for traffic bridge. And then evaluation of foundation condition for both abutments and the piers requires, because these two zones are going to bear all the load transfer through piers and supports pillars to the foundation and abutment strata. Then for construction of the project, it is necessary to identify the availability of aggregate materials and building materials in nearby area and some soil materials for soily foundation. Important aspect is a selection of site, and the selection of site is a very important. The selection of site depends on the topography of geoground, then the hydrological condition of the river or flowing channels, and the condition of rock strata or soil condition for evaluation of their ability to bear the load of superstructure as well as dead and live load of traffic or in another way imposed load due to various activities of humans. The engineering geological and geotechnical problem and approaches of study in view of geoground are divided in two categories. One is mountainous or hilly terrain and other is alluvial deposits. Alluvial deposit confined to the river valleys at different levels and different reaches. First we are going to see about the condition of river for locating the bridge in different situations. Before discussing about recommendation concerned to types of bridges, here we are going to see about the elementary features of river. And a river that originates in a high mountains terrain flows through steep and narrow valley at the upper reaches, then gradually broadens its valley as it descends down to the fan out in the plain, and finally responsible for formation of delta. The flow of water in rivers through the hilly terrain with steep gradients, and it forms terraces with thick deposit of boulders, pebbles and sand at different levels along with the banks, but of limited thickness. In alluvial plain area, the rivers are generally large and carry huge load of finer sediments. Then the banks are decorated with fine to medium sand and as well as silt and clay on river banks with different terraces representing the different levels of river with respect to time in past history. In view of various kinds of deposits and landform, the site for construction of bridges are different in different parts of river or river form landform. In view of gradient characteristic of water flow and nature of deposits and their constituent, a river course is divided in three parts: upper reaches, middle reaches and lower reaches. This upper reaches, middle reaches and lower reaches is based on decreasing gradient of lands. So first we are going to see about the upper reaches. Before this discussing upper reaches, here I try to show about the bridge in different reaches. Here this upper part at higher elevations, it is recognized as upper reach, and then plain area when this river is going to broaden, here the narrower side, then it is a middle reach, and the lower is a further widen and recognized as lower reach. So first we are going to see about location of bridge at different reaches and particularly in upper reach. Friends, as you know, in this part of river the valley is narrow and V-shaped, and in this part the rock strata is generally found exposed on both the banks with very limited thin shallow cover of overburden consisting of boulders, pebbles, cobbles and some finer sands. The terraces are rarely formed and the hill slopes are comprised of rock strata. It means the banks along this narrow strip of river is made up of rock strata which are able to sustain sufficient load, but as the valley side is narrow, therefore the condition of the strata suitable for bridge construction should be stable hill slopes of strata on both sides of a river, required for suitable and economical construction of bridge. What is the recommendation? This part or this reach is suitable for construction of single span bridge as the span of this zone is limited in width. Therefore, single span bridge is sufficient to solve the purpose, and the sufficient purpose solved by the single span bridge supported on two abutment and can be constructed in such high altitude hilly terrain. So in summary, we can say that keeping in view of the rock exposed along both the bank and the narrow span of river recommends the construction of single span bridge, that is economical and stable also. However, such situation of the upper reach encounters certain type of critical geotechnical problems, like the strata or the ground is affected by the rains and traversed by jointed rocks of the hill slopes, or debris deposit on banks may cause problem of slide and instability to choke the water of flowing water in river valley located in upper reach. In this high altitude, the melt water from snow during summer and the rain in monsoon causes an abrupt increase in flow rate and consequent rise in the water level, causing flooding and others, and may disturb the abutment of the single span bridge. The huge deposit of boulder materials or pebbles, cables and others may sometimes block the flow path, creating sudden rise in water level and flooding, which is hazardous for developed bridge. The rock cutting of the abutment is a common hazard in this area due to high velocity of water flow, able to cut even strong rock strata also. And then it is important to have idea about the hydrology of river with respect to maximum water level or flood water discharge, so that the proper design of bridge can be formulated suitably to minimize such type of problems. Keeping in view the data regarding the snowmelt as well as rainfall based on daily records, weekly records, monthly records and yearly records. In case of middle reach, as you know, in middle zone the river width is in increased fashion than the upper reach, and in middle reaches the river valley become broader and the terraces are formed nearby the banks of river. So a bridge at the site in the middle reach with wider valley will require more piers, one or more piers and abutment for supporting the superstructure, because the superstructure to cover this wider zone is of heavy nature, requires more piers in addition to the abutment for supporting the weight of superstructures along with imposed. The middle reach is actually a good site for bridge construction if the rock exposures lying at shallow depth. If rock exposures is lying far below the upper layer or soily layer, then the construction of bridges in this area is a problematic and requires more money for various type of investigations and modifications in design. It is also to be ensured that the vehicles coming from the road along with the foothills have sufficient space for turning to move over the bridge, and the hill slopes along the proposed site should be stable if we are going to construct a long bridge. In addition to this, we require information regarding the hydrological condition of river, so that we can assess about the flood chances and rate of erosion as well as the flooding zone, etc. Then about the rainfall and presence of weak features below the soily layers and the condition of the bedrock, and if hilly region is located nearby, then the slope of the hilly regions to avoid the problem of landslide and the weak foundation, etc. In case of lower reaches, as you know, there the velocity of river is very low and the spread of water is more due to low gradient of lands on which the river is flowing. In this region, the deposit is mainly made up of very fine sediments belonging to silt and clay. Friends, as you know, the clay have various hazardous effect in form of swelling characteristics and absorptions of water, etc., feasibility, etc. So in lower reach, the river is generally quite broad and it has already attained the maturity stage and will debouch into the plain with the fine deposit consisting of mainly silt and clay type of material. The bridge is to be located at sufficient higher level to avoid the choking of materials consisting of silt and clay, and the approach road for the bridge may be taken through the plan, and the roads connections with the river plain area to this lower reach is a very important for supply of suitable material and facilitating the traffic toward the lower reach. Then with proper gradient to the higher level is assessed properly, and this may involve excessive cutting of the foothills area or making tunnels to connect the bridge in the lower reach area if the situation is not suitable for construction. As the river valley is broader than the river valley in plain area or upper reach, therefore a long bridge is required to construct, which requires number of piers to be located. Some of the piers may be located within the water body. Needs special precautions and techniques for pilings and others. We have already discussed about the strata or layer located at different levels. So for the upper reach, the rock exposures are available which are sufficiently strong and of high quality that can bear the load of superstructures. Due to narrow valley, this type of regions require single span bridge which is not heavy in comparison to multi-deck or multi-span bridge. In case of middle reach, the river is in advanced stage and form a well-defined channel of considerable width, requires multi-span bridge with number of piers besides abutment, and requires detailed subsurface engineering geological investigations through mapping, through geological section preparation, through exploratory drilling, etc., along with geomechanical property evaluation of rocks as well as rock mass lying below. In lower reach, the similar situations we are facing require long bridge, and this long bridge requires a number of piers. Some may be located in water body also, requires special precautions on one hand side. On another hand, the typical behavior of silty clay and clay requires careful experimental work for determination of liquid limit, plastic limit, plastic index, bearing capacity, cohesive strength, angle of internal frictions, and others. The investigation for bridge sites of the lower reach may carried out same way as in middle reach, starting from the geological mapping to exploratory hole drilling, sampling, and then evaluation of collected samples in laboratory regarding the strength, bearing capacity, index property, etc. The site selection for bridge in alluvial plain is a typical example of bridge construction in middle reach of a river. Friends, as you know, the landforms or landmass in the plain consisting of soils or unconsolidated sediments of considerable thickness and bedrock located far below the soil cover in alluvial deposits, for example Indo-Gangetic plain, where we are getting the bedrock far below than the thickness of soil or earth materials. This alluvial plains is generally traversed by number of streams, nala and rivers. To cross these rivers and connect the road from different locations requires construction of bridges in alluvial plain. As the river is in mature condition, have considerable width of the channel, therefore required special attention regarding the construction of bridges in alluvial plain area. As far as the alluvial plain is concerned, it is drained by number of streams, nalas, river, reservoir, ponds, lakes, etc. Therefore, number of bridges are required to cross water bodies and connect the road and highway in alluvial plain. In single span bridge to be constructed across a small terrain, however, medium type of bridge are more than one span bridge is required for the streams or river of considerable width. However, the rivers having higher width requires multi-span bridge. The multi-span bridge is require number of piers to support the structure. In case of medium bridges requiring construction of one or more piers, the foundation of pier side, if any, has to be investigated in addition to abutment to ensure the bearing capacity of foundation strata or soily layers present in area below the piers as well as abutment pillars. The sites for large bridges over broad rivers involving construction of many piers to cross the river due to higher width of river channel, including some in the underwater environment because due to broad channel, this broad channel is not always able to provide land to the pillars for the support and requires detailed surface and subsurface geotechnical or engineering geological investigation with help of exploratory drilling for each of the pier sites and two abutment sites. As the bridge concerned with the multi-span bridge, therefore the load of superstructure as well as the dead and live load of traffic or imposed load due to any cause related to human activity requires number of piers excluding this foundation to support the heavy load of traffic as well as superstructure. Therefore, the subsurface status of soily layers as well as rock strata is necessary to evaluate. The evaluation should be related to the geotechnical response of strata or soil layer to show their bearing capacity with respect to planned or expected load due to bridge. The construction of such a long bridge over a large river is required to involve construction of many piers to support the superstructure and bear the load of traffic. So, a detailed geological, engineering geological, geotechnical investigations are required to see about the lithological distribution of subsurface strata or layer, then about petrological characteristic of subsurface strata or layers, as well as the bearing capacity, cohesive strength, shear strength, compressive strength, tensile strength of rocks, as well as soily material or loose material. In addition to this, the soily materials requires engineering index properties like liquid limit, plastic limit, and Atterberg limit, then cohesive strength, angle of internal friction, consolidation, compaction, swelling potential, etc. The exploration of drill holes will provide information on subsurface conditions. For this, we have two types of drilling system, rotary and percussive. Through both, we are going to collect samples through samplers and to establish a suitable log, either belonging to the rock lithologs, either belonging to soil lithologs. In this way, we are going to see about the actual situation of subsurface strata lying below the proposed bridge foundation or pier sites. The design load consideration, the structural load and hydraulic factor, engineering geological investigation has to ensure that the strata on which strata as well as layer on which the piers and abutments are rested above adequate capacity to resist the forces as in design load or expected imposed load. For this, we are going to adopt three methods. One is the development of pits, another is exploratory drilling, another is creation of trenches to see the actual condition lying below the abutment or along with abutment or below the piers, etc. Generally, in alluvial plains, we are going to drill about the exploratory drill up to 30 to 50 meter depth at each pier site to ensure about the sound availability of sound strata, and then collection of the samples from different depth level by using special sampler so that the collected samples can be evaluated in terms of engineering geological parameter, particularly related to the strength and quality. For this, we are going to determine in our laboratory regarding the shear strength, compressive strength, swelling potential, liquid limit, plastic limit, and Atterberg limit, then grain size, distribution of grain size, about the maturity, compaction, etc. in laboratory, particularly in case of soil. In case of rocks, we are going to characterize rock strata in view of rock mass characterization and evaluate the quality of the rock mass, and then the strength of rocks, modulus of rocks, and Poisson's ratio of rocks, various types of modulus like second modulus, tangent modulus, average modulus, bulk modulus, modulus of rigidity, etc. After estimating different mechanical and geotechnical, engineering geological property. Then we are going to develop a litholog along with different details in summarized way about grain size for suppose for soil, grain size, about the heterogeneity, about cohesive strength, about angle of internal friction, compressive strength, shear strength, liquid limit, plasticity index, Etterberg limit, so and so. So in this way we are going to see the variation of the grain size, variation of the heterogeneity in term of it is homogeneous or heterogeneous. In term of cohesion we can see, in term of angle of friction, in term of compressive strength, in term of liquid limit, plastic limit and others. So in this way we are going to visualize all the geotechnical attributes of the soil, and similar concepts we are going to adopt in case of rock. To know the strength, to know the texture, to know the microstructure, to know the lithological distribution characteristic of rock mass, different strength related properties, etc., which can ensure about the bearing capacity that can withstand with the imposed structural load as well as imposed load of. Then the geological sections and the soil characteristics we can evaluate by making some soil sections and by drilling and collection of samples and etc. Then about the foundation on hard rock, this foundation of hard rock requires minimum problem only related to evaluation of strength of rock as well as quality of rock strata as good, excellent or extremely good, etc. Then about the hydrological condition and availability of water regarding the saturation. Then we have properties concerned to compaction as well as the hardness and durability. In case of the foundation belonging to the rock strata, we require minimum problem, and then problem may arise if there is a presence of some seams, some pockets of weathered material or some unconsolidated materials or some weathered zone or some strata prone to swelling, etc. If such type of hazardous zones are available in rock strata, then requires careful preparation and treatment and suitable measures to strengthen the rock strata for supporting the load of planned and designed bridges. Regarding the construction material, the bridges are constructed with help of masonry as well as with help of concrete. For making concrete, we require aggregates. The aggregates nearby area, if available, then most welcome, and if not available, then we have to calculate about the transportation cost, because in any project the transportation of material is a very important and the cost of transportation should be mentioned properly. The cost of transportation sometimes going to enhance the budget of proposed project. In case of upper reach, there is no lack of materials, sufficient rock exposures are available. In case of middle reach, the rock aggregate, we are going to utilize cobble, pebbles and boulders for making aggregate regarding the concrete work. In lower reach, there is a problem. It requires more transportation cost for development of bridges. Friends, the material for this lecture were prepared with help of book written by Gangopadhyay S, named as Engineering Geology, published by Oxford University publication. Then partial supports from the book of Engineering Geology written by Well F.G., having page 1 to 5.1 thick book, and then partial supports from the textbook of Engineering Geology written by Kashabulu NC in 2016, having page 1 to 495. Friends, today we have discussed about the engineering geological consideration of foundation and abutment zone. The foundation strata is required for categorization and characterization because the foundation and abutment strata is going to hold the whole load of structure, along with imposed load in form of dead and live load of traffic. The bridge stability depends on the mechanical response of foundation and abutment strata or soily layers if the abutment is made up of soil, or foundation zone is made up of soil layers. As per gradient, the river channel can be divided in three broad categories like upper reach, middle reach and lower reach. The construction of bridges recommended in upper reach, middle reach and lower reach depends on the characteristic of river channels as well as the strata lying below the proposed piers and abutment. In upper reach, the single span bridge is sufficient to serve the purpose. However, in middle reach it requires one or more piers in addition to abutment pillars. But in lower reach it requires more than 2-3 more pillars to cross the broad valley and require very extensive geological, engineering geological and geotechnical investigations through geological mapping, preparation of section, exploratory drilling, application of seismic techniques and other techniques related to ground penetration radars and etc. are utilized for subsurface investigations with laboratory work to determine about strength, modulus, Poisson's ratio, cohesive strength, shear strength, angle of internal friction, etc. The types of bridge depends on the part of such reaches. We have already discussed upper reach, single span, middle reach, one or more piers required, multi-span, then in lower reach, many span with requirement of number of piers more than 2-3, and some of the piers may be located in water zone. The alluvial plains requires detailed engineering geological investigation for identifying suitable foundation rock because the alluvial plain is consisting of different layers of soil as well as rock strata at considerable depth. Therefore, detailed investigations are required to identify suitable sites for construction of them. Dear friends, in this class we have elaborated about engineering geological facets of bridges, quality and source of material, and geotechnical aspects related to geoground and geotechnical problems. The foundation of bridges are of different type depending on the nature of strata. The strata is located in dry land or strata or layer is located below the water with shallow level of cover of unconsolidated material over bedrock or considerable depth or very thick overburden over the bedrock. The different type of foundations concerned to construction of bridges along with foundation of buildings we will discuss in our next class. Thank you very much for your patience.